Now, on a previous video, you'll have seen this sort of thing where we have 5 situations or events, we called them, okay, where we did it on a chance line. Now, what you'll see with these sorts of things is that actually it's normally done horizontally. We did it vertically here, okay? Now, the impossible bit normally goes right over here on the left, and the certain bit normally goes right over there on the right. So I'm going to write them on there, certain and impossible. Okay, so there we go. Now, what I've done again, like this one, is I've got an evens in the middle. So we'll put evens there as well. Okay, and a bit more of a problem is going to be this bit and this bit. Now, between certain and evens, we had likely in here, all right, and we had unlikely, didn't we, between evens and between impossible. So what colour did I use for that? I used blue. So unlikely. Now, we're going to try and put some numbers with these sorts of things. Now, evens, we said, it was the example we had, if you remember, was flipping a coin and getting ahead. And we discovered, didn't we, we had half a chance of getting ahead. So I'm going to put it as a fraction. You could use it as a decimal as well. So half goes there. So 0.5 or 1/2. They're the same thing, we can use either, okay? And this is the start of, now we've got fractions or decimals on there, of calling it a probability line, because we're putting numbers to these situations. Now, impossible means I've got no chance of something happening. So no chance, what number do you think is going to go with that? Well, we're probably going to put 0, aren't we? Nothing, all right? So no chance. And then we've got 0, 1/2. Well, we've done sequences before. That's pretty straightforward, is it not? This is going to be 1. Okay? Now, that just means that we can put numbers to certain, evens, and impossible. But we had these 2 others, didn't we? We had probability of right-handed, we had the probability of getting a lottery win, or the chance of getting those. Now, if I'm going to put numbers to these, I need to call it probability rather than chance. Unlikely, likely, evens, that sort of thing, that's called chance. Numbers means probability. So I'm going to look at this right-handed one. Now, the right-handed one, if you look at statistics across the country, okay, about if you have 5 people, 4 of them would be right-handed and 1 of them would be left-handed. Now that gives me a probability of about 0.8 if you use your calculator, or 4/5. So 0.8 or 4/5, if I split it up into 5 bits, so there's 1, 2, 3, 4, it's going to be about here. Okay, so this here would be the right-handed example that I had before, and that is about 0.8 or 4/5. It doesn't really matter which one I use, okay? So there you go, there's your probability because it's got a number to it. Now the last one, the lottery win, now that's really, really small. Actually, if you look it up on the internet, if you Google it, other search engines are available, okay, you can find that it's about 14 million to 1, or 1 over 14 million is the chance or the probability of winning the lottery. Now that's really, really small. That's 0.0000001 or whatever it is. You could use your calculator again. So that's really, really small. So even though it's not 0, because I do have a chance of winning the lottery, probability is tiny. It's about 1 in 14 million here. So 1 in 14, 1, 2, 3, 4, 5, 6. There you go. Not sure what that is exactly as a decimal, but I could write that as a decimal as well. Okay, so there's your probability line. It changes from being a chance line to a probability line because it's now got numbers attached to each bit of it.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.